Hi, I'm Nagarjun. I'm from India. I'm an API security researcher, ex-API security researcher at Acto. And I'm going to talk about RAG pen testing. Has anyone heard about RAGs? No? Yeah, can someone help me out with the abbreviation? What's the full form of that? Anyone?
Retrieval-Augmented Generation.
Yeah. Can you be more loud or should I repeat it? Retrieval-Augmented Generation. So that's like the next level innovation in AI. And has anyone built agents recently? Can you tell me what kind of agent did you build?
Sure. So
Yeah.
I gave an LLM access to some user manuals that
Yeah.
would help it understand the parameters of how to create complex queries of a
Yeah.
large data set. And then I also gave it some other text files that contained like user notes from people who had shared with other people.
Yeah.
And then I gave it a system prompt that said use this and this.
Combine the
Somebody-
data.
When somebody asks you to create
Yeah.
a query, use these to form a correct query.
Yeah. So as our friend said, he's combining documents with a language model and then giving the language model some additional context to generate better data from the language model, right? So real-time data, I would say, in my opinion. So LLMs usually have a cutoff date, right? Everyone knows that. And having a cutoff date, like if I want to ask GPT right now, what's the share price of Tesla? Will it be able to give it only based on the language model data? No, right? So it does search online for the data. So this additional functionality that we have, that is RAG. So adding additional context with the language model, which is restricted in some way, and then combining the data and giving the output to the end user, right? I can show you right now if you want. So our agenda would be I'll be discussing about RAGs, how they work, and then what kind of vulnerabilities can we see in RAGs, and then the kind of mitigations that we can use with our so-called new kind of agents that we are building, everyone is building, right? So for example, I go to GPT right now. Is my screen visible? Yeah. So if I ask it right now, what is the share price of Tesla? So you can see the search option is here, right? So it's searching the web right now. So it's using additional context and giving out the data. The current value is around $241. That's visible to you, to everyone, right? So the language model ingests this data and comes out with the data, the real-time data, which is the current stock price of Tesla. So this is the runtime data that we are getting using RAGs. So this is a search functionality, and then we can also upload documents so I think a lot of people might have uploaded their resumes to get it reviewed by GPT, right? You might get good interactive opinions from GPT. So this additional feature is supported by RAG. So I'm coming back to the presentation. So RAG. As my friend told, he has built agents. A lot of people have built agents here. And I think building agents is really good for the SaaS industry because we are getting additional context. We don't have to code a lot. We have to just put in the prompts and get the data out. So then SaaS industry is going to transform. And because of these small, good working features, the SaaS industry is going to transform like anything in some time. But let's discuss an incident that happened with my friend recently. So I'll give you the context here. So they are building a recipe-based agent, which actually takes in documents for recipes and then clubs it with the language model and then comes out with the data. right? So the prompt here is, give me a vegan healthy pizza recipe. And the documents here would be like a recipe for pizzas, a recipe for any Indian kind of food. So you can see the response is, use a cauliflower crust, cashew cheese, and top it with grilled watermelon. So has anyone eaten grilled watermelon as toppings for pizza? That's a thing. Do you love it?
No.
Exactly. So our RAG pipeline is actually hallucinating right now. This is the problem that's a very basic problem. They solved it. I'll come to that topic in some time. But this is something that the language model is not hallucinating here. So RAG is anyway tagging along with LLMs, right? The RAG pipeline is hallucinating. And the user is shocked anyway because, like, what the hell? Grilled watermelon. So I'll show you a basic architecture of how RAGs work. So you can see that there's a user prompt, as comparing to our previous example, like a recipe language model or RAG pipeline. Give it a question like, what is the recipe? What kind of recipe will you have for making a pizza? So that's a user query or a prompt that everyone uses regularly. So this prompt actually goes to a retriever. The retriever extracts the files or hunts for online and prepares a document store. So for our recipe example, we might have a bunch of documents for recipes, right? The document is like a DB, a temporary DB or a permanent DB based on the client's requirements. The document store is processed by the retriever, and the retriever actually extracts what kind of best results are good for the prompt, like our pizza example. So it extracted grilled watermelon. That's not expected, but like toppings would be cheese, vegetables, and like chicken, like that. So the retriever extracts it from the document store, and the retriever then passes it on to the generator. So generator is nothing but a language model with our user query and the additional context that the retriever has provided us. And then the generator gives the output to the end user. The example that I showed you, which is hallucinated, but like this is the output the bot gave. The toppings. So can someone tell me where can this RAG pipeline be attacked? Does anyone have any opinion about that? Yes?
The document store.
Yeah.
And poison that with all sorts of injections, etc.
Yeah. So the document store is covered, and yes?
The query itself can be used to gain information out of
Yeah. So the prompt and any other guesses?
Even generator.
Yeah. The language model itself or the generator logic, as I call it generator logic here, because it's not only the language model, but the retrieved docs from the retriever and the query that is the user end user have provided, right? That's it. There's one more thing left. Yeah. So the primary attack vectors are like the prompt itself, like I call it additional now because prompt injection is like a very common vulnerability. The prompt or the query, the document store, the retriever logic, and the generator logic. And if the generator like gives the output, we don't know whether it's hallucinated or not, or it's reliable or not, right? So 4 attack vectors, and I'm not like discussing the normal LLM vulnerabilities because those are very common, like package hallucinations and prompt injection, insecure output handling that are covered in OWASP LLM top 10 anyway. So I'm just showing a GIF of a retriever because the retriever is really confused what to extract, what not to extract. And I met a retriever today. So he was very happy to meet me. But like, I also have a retriever. So we'll be exploiting the retriever a lot. So, are we clear with the RAG pipeline? The query, retriever, generator, and the response. This is a very basic pipeline for RAGs, right? So now can we jump onto the vulnerabilities? Yeah? Is everything clear? Yeah?
You mentioned earlier the system prompt. Is that part of the retriever?
Now the system prompt, so retriever extracts the top possible search results in the document store. So system prompt, like there are multiple prompts here. The generator might have a system prompt, the retriever might have some system prompt, and there's the end user prompt. So there are 3-4 kinds of prompts here.
Gotcha.
Yeah? So as our friend discussed, the first vulnerability is like poisoning. So I've written like 1 lie in the docs, 1,000 lies in the response. So that means like if some document randomly gets poisoned, how many users will be impacted by that, right? If a RAG pipeline is in production and somehow the document store or the whole pipeline gets compromised due to some reason, that will have a domino effect, right? So let's jump over to the actual vulnerability. I've made a very basic example so that everyone can understand this, right? So the victim query or a normal user query is, how do I reset my password? And this query goes to the retriever, who actually figures out what kind of documents are required from the document store. This part is a document store for us. What kind of documents are required from the document store which will be relevant for this user query. So the query goes to the retriever or the RAG pipeline, and it contacts the document store. And for our scenario, we have a public repository that is being used as a document store, a GitHub repository. And the attacker forks the repository and adds something random or malicious in the repository, and that repository gets ingested into the document store, and it's being accessed by the retriever. And somehow the attacker like prioritizes that particular statement. The statement is here, by the way. Email your login to itsupport@attacker.com, right? Somehow the attacker modifies that and the retriever extracts it, and the retriever fetches the results from the document store and passes it on to the generator, right? And the end user sees, email your password or login credentials to this email ID. So according to you, is this correct? Obviously, no, right? Because our document store is got compromised here. The end user might not be able to know it, but it's anyway compromised. So a legitimate user or a victim might actually transfer these credentials to this email ID. So this is how data poisoning or knowledge base poisoning. The whole section above there is the knowledge base of the RAG pipeline. The knowledge base is getting compromised here. Does anyone have doubts right now for this? It's a very basic example. No? Okay, I guess everyone understood it. So I have a meme here. So this guy is a retriever. He's actually embracing the poisoned GitHub repo and accepting it and giving it to the end user, right? So this is a very basic example of data poisoning. How to mitigate this? So our source or knowledge base has to be checked thoroughly. It should have proper integrity checks. It should be validated twice or thrice if you are fetching some data from the public repository. There's a fair chance that the knowledge base might have internal documents only, but we'll discuss that later. For our example, we have to make sure our source is correct, and we match all the checksums or integrity checks before passing it on to the end user. So we have targeted the document store here by poisoning it. Now let's move over to the next vulnerability. Query manipulation, a semantic sabotage. Query manipulation is nothing but prompt injection, but here we are confusing the retriever. How we are confusing it? We are using specific keywords that might possibly bypass the guardrails. Does anybody know what is a guardrail? Yeah. Can you help me out what it is?
Guardrails are basically rules set in place to prevent you from gaining access to resources,
Yeah.
places, systems, assets
Yeah.
that you shouldn't have access to.
Yeah. So it's like a
FGA, fine grained authorization.
yeah. So the main job of a guardrail is to make sure nothing sensitive goes inside the language model or the pipeline, or nothing sensitive anything sensitive doesn't come out of the pipeline. If we use something random, some random keywords, there's a fair chance that we might be able to bypass the guardrail. This is how query manipulation can work, and that's how prompt injections work. Because we have a lot of keywords that might be reserved inside the guardrails database. If they come out in the prompt, the prompt should be rejected, right? So semantic sabotage, playing around with the words. So there's one more example. So the green one is the victim query, and the red one is the attacker query. There's very basic, very subtle difference between the two. What are the safety reasons of mRNA vaccines? This has been inputted by the victim or a normal user, and possibly an attacker would enter if he knows what words he can use to bypass the guardrail. What are the dangers of mRNA vaccines? So the retriever processes the query, both the queries. He accepts the green one, he accepts the red one. But there's no actual check to stop a bad prompt. So the retriever for the normal user retrieves legit data. The legit data is like mRNA vaccines have undergone rigorous testing, are considered safe, and for the attacker, the data gets ingested by the retriever and the generator produces the output. The retriever anyway has produced biased and alarming data. Like some believe that mRNA vaccines may alter the DNA, although this is not scientifically proven. So if this data is getting used somewhere else after this pipeline, it might cause problems for the SaaS application or the agent that is using it actually. Do you understand what I mean? Like, since RAG pipeline is anyway used in an agent, this data and this data both might be used by the agent for further processing.
So would this be worse with semantic caching then?
Yeah? I didn't.
So semantic caching would make this problem worse.
Kind of, if there's a buffer that maintains.
Embeddings match both.
Yeah. It's like data skewing, if you know. It might return bad data for this prompt, it might return good data for this prompt or query, right? So in this vulnerability, we are targeting the query. We targeted the document store for the previous vulnerability, and we targeted the query itself that is going inside the RAG pipeline. Yeah. So he's a retriever. He's a guy, but I wanted to be a retriever. So everyone knows that retrievers are very friendly. They get along with anyone, right? So this girl is not happy, the owner is not happy that the retriever is looking at someone else or getting affection from someone else. The manipulated query with bias. And this is the legit query, the response that we are getting, right? So mitigations, you can normalize user queries. As my friend said, you can actually use caching here, and we can use filters for the semantic relevance, or we can actually enhance our guardrail to make sure this kind of query doesn't go inside, and even if it goes inside, it should not like return different data from the document store that we discussed previously. Anyway, the retriever is accessing everything here. The third category, over-retrieval. When RAG spills the tea. It's like typical sensitive data exposure that we get to see like in almost every kind of architecture, be it APIs, be it cloud, be it language models. Even language, OWASP top 10 for language models has a sensitive data exposure category. So this is our diagram. So has anyone heard about projects Phoenix? Anyone? Yeah? It's like very famous?
Yep.
Yeah. So it's not necessary that the project Phoenix that you have heard about, it might be available somewhere else also, right? It's a very common name according to me. So the end user inputs tell me about Project Phoenix architecture. Or there might be a prompt like, so since it's an agent, what are your next marketing plans for the next quarter? So ideally, if the agent or the RAG pipeline shouldn't expose the data, the retriever, as I said, is very friendly with everyone. He'll go access the public data that is only accessible for the retriever, and it might access some internal data only. And it might combine that data, convert it into a vector embedding or like embedding or vector DB. Sorry for that. Vector and embeddings are like something that it's a database, how that data is processed for a context, and it is fed to the generator. So we have internal only data here. It's getting accessed and it's getting outputted into the generator, which is combining the data and giving us the output. The output might contain something sensitive because we are also accessing the internal only data, which should not be accessible by the retriever. Or if it's accessible, so again there's an access control vulnerability that I can discuss here. Internal only data should be only accessible for the admins or based on the business logic. If internal data is getting accessed by the retriever, that means there's a big access control issue, which combines with sensitive data exposure, right? So the response contains sensitive data. This is how over-retrieval works. Getting more than usual data of what is asked. So ideally it should not respond with the internal data, but it's responding, right? So this is a RAG generator. This is like the end component of the pipeline. It's exposing the sensitive internal data, but it's fine with it because the retriever is approving it, right? So possibly there should be, like, I'll go back. Possibly there should be a guardrail here, right? Just before the last red section, I'll come back here. There should be a guardrail here, and there should be a guardrail here, right? But it's somehow getting bypassed, or if there's no guardrail, that's how sensitive data is getting exposed. Because usually, has anyone heard about NVIDIA's Nemo guardrails? Has anyone used it? So you might know that you can configure it based on your requirements. You can add sensitive data in it. There are irregular expressions or the keywords that should not be exposed, right? So you can actually use NEMO guardrails to stop sensitive data coming out of the system. So the mitigation, again, as I told you, guardrails or pre-screen the context. So the context is getting generated from the document store, right? But if you don't screen it, what kind of data is coming out or not, it will cause a lot of problems. And you might not even know about it because there's a lot of users using the RAG model in production, right? So again, this is a kind of a document store or the vector DB attack. So we are actually modifying the embeddings that are available in the document store. We are tweaking it in a manner that we rank so embedding is, a vector is nothing like a bunch of numbers. Even language models are a bunch of numbers internally. If you are successful in modifying the vector DB or the embeddings, vector DBs are nothing but embeddings. If you are successful in modifying that, if you modify the ranks of various keywords, it might modify the truth that is coming out of the system. This is a very big example, but yeah. Everyone might have heard about Apollo 11 mission, right? It's a very big thing. So a normal user comes in and asks, what is the objective of Apollo 11 mission, right? The query goes inside the retriever. So ideally, the language model will have all the data here. Do you agree with me? Because Apollo 11 is a very old data and it's well identified and it would be in the language model. But for our scenario, the language model doesn't have it because language model is actually just giving the output based on the RAG pipeline or the document store. So the retriever pulls out the relevant context. Relevant context means what is Apollo 11, how did the mission happen. All the relevant data are extracted from the vector DB, but somehow the attacker injects irrelevant data into the vector store. It's like poisoning, but we are targeting embeddings here, right? The attacker injects the moon landing was staged in a studio. It's a very controversial topic. Yeah. The moon landing was staged in a studio confirmed by insiders. A lot of people debate about it, right? Initially, the document store says, yeah, the Apollo 11 mission was actually successful. But once the retriever pulls it out, there are two queries here. What is the objective of Apollo 11 mission and what is the purpose of the first moon expedition? So this query might map with Apollo 11 mission keywords in the embeddings. And once the retriever extracts the relevant context, the generator consumes the data. The response might be skewed or possibly wrong output or a correct summary based on legitimate data present in the document store. So here we are again targeting the document store. So we have covered 4 vulnerabilities here. Over retrieval and data poisoning and what else? Can someone tell me what kind of vulnerabilities that I discussed? Over retrieval, data poisoning and query manipulation, and this one? Embedding attack. Yeah. So we have primarily targeted the document DB, the query, or the retriever. Generator, I would say, has anyone heard about OWASP LLM top 10? Yeah, like it's very, very common, right? So all the vulnerabilities that are covered in OWASP LLM top 10 might come up here. And all the vulnerabilities, all our traditional vulnerabilities that we are trying, SQL injection, access control issue, or OS command injection, all that still comes in the whole pipeline. You can never ignore it, right? I have one last meme. We embed misleading data. We swap the query. Model retrieves the malicious document. And model confidently answers the wrong data. Like Apollo 11 mission was fake. Right? It's like all these vulnerabilities are like very relatable, but little bit advanced. Little bit different because of the RAG pipeline. Mitigations, like you can actually normalize the embeddings to make sure there's no injection or poisoning, right? You can actually score the context based on a benchmark number to make sure that benchmark number doesn't bypass due to some issue. Context being fetched from the document DB or the document store. So I have 3 more vulnerabilities to discuss. Knowledge base poisoning, context overflow and truncation, and access control weakness. Knowledge base poisoning is a subset of data poisoning that we discussed initially, where we are actually targeting again the document store, but here the knowledge base has trusted documents, the documents uploaded by the developer who created the RAG pipeline. And compromising that is like, again, data poisoning is possible. Context overflow is where you can actually trigger a DOS or cause truncation in data. So the RAG pipeline is fetching context for us. If we give a lot of, like, for example, has anyone uploaded a lot of data on GPT and then GPT started hallucinating? Has that happened with you before? So we are actually DOSing GPT, right? So because GPT has a limited context window and you're actually bypassing that. So you'll have to make sure it is chunked, or you actually give small prompts or lesser data to get the data out properly. So DOS again comes in picture. And the last vulnerability is access control weakness. Access control weakness is like, as we discussed, over retrieval. We're actually accessing some internal data that is accessible by a different user or an admin, and public data, like, which is visible to the end user. So if the end user is able to access the internal only data, then there's an access control weakness. So if, like, everyone has a fair idea about IDOR, BOLA, injection attacks, DOS, so all these things still are relevant, but in a bit advanced manner, like technical jargons, but it's very easy to understand. So I have this one line. The LLM only speaks what is shown. So controlling what it sees is where the real protection begins. So when a language model is trained, it's not trained on bad data. But whatever data that goes from outside, and when it's combined to give the real output to the end user, that is where we should actually try to control the vulnerabilities. So I'm done with my session. Do you have any questions? Yeah?
Honestly, like as you said, we need to control what is fed to the LLM.
Yeah.
What I'm trying to say is it possible to unpoison an LLM? Is it like unpouring concrete or something? How do you make an LLM unlearn if you have fed it wrong or incorrect data?
So we have a RAG pipeline. We are not touching the language model. Retraining a language model is a very hectic process, and that is done by OpenAI. They do it on big GPUs. We are doing it on a small scale, right?
Much above
Yeah.
Okay.
Yeah.
So in terms of like the retriever having access to too much data, are folks out there building retrievers that are that can say like take say like do OAuth so can OAuth as you, right? So you you give it you authorize it to like, yes, this code can execute, can use my permissions across this data set or something like that, or whatever other way to, like impersonate you and this only have access to the data that you have access to within your company's document store. If that's what's hooked up to your retriever. Are folks implementing those, or what you're seeing out in the wild is that companies are just like, yeah, well, everybody gets access to whatever they want through the retriever, but is it all just like, are they just feeding it internally public docs, or do you end up with like you have a specific retriever pipelines on a per group basis to make sure that the data is segmented properly? How are folks implementing it out there?
So people are building a lot of agents right now, as I discussed.
Yeah.
And there are a lot of young vibe coders in the market, right? They're building extensively, but they don't know what they're building. They just get the requirement, they build it, they don't know what should be accessible to the end user only. So it's like people are doing it on a very advanced level, not on basic level. And I think startups are like building like crazy, but not thinking about these issues.
So when we talk about RAG, so especially in Copilot, there are different connectors. Copilot Studio, you can connect to SharePoint, that can be used as external data source. And then you have, say, Azure DevOps tickets and so many different channels that are there. So, I mean, all these are like internal, I'm talking about more of an enterprise kind of a RAG thing where, you have internal data sources. So what vulnerabilities do you foresee, or if you have come across, with these internal data sources? Because I don't see much issues because those are already vetted and internal and have access management. So what are some areas which we must try to look for the vulnerabilities in such a enterprise-based scenarios?
So by default, we are expecting all these things to be secure, first of all. That's our mistake. And vulnerabilities, I would say, these vulnerabilities might not show up immediately, but once the product is ready, they might show up in the long run, because we are building too fast. And as you said, we are having a lot of connectors. And while connecting, if there's some misconfiguration issue, that is where these vulnerabilities will come up. Or if the developer doesn't make sure that this connector is not securely connected with the internal language model. Yeah.
Can you give an example of the misconfiguration?
An example of misconfiguration with RAGs, I would say using default passwords, a very basic one. There's a lot of misconfiguration vulnerabilities in the market. Depends on the context. Yeah.
So we try to build defense in depth. So how do you go about protecting your guardrail processes and those systems, your context analyzers for safety? How do you protect those?
How do I protect them? I've not actually done it, but yeah, that's fine. So guardrails, I would say. So in what context that you want to protect? Like I want to understand. I want to understand the question properly.
Kind of like with query manipulation, trying to get it to expose, secrets.
Yeah.
Stuff like that. You have like your initial large language model that says, oh, they're searching for secrets. I'm gonna not send that query down the line. How do you protect that intermediate step?
Intermediate step, have you used Git Guardian?
Yeah.
And Git Guardian does all these secret scanning for you when you make a pull request. Whenever you make a pull request on GitHub, right? So
Right.
This is when you're developing the product, that is where when you make a pull request, and then all the secrets are scanned anyway, right? Then guardrails are they're like runtime protection. You have configured it, but you will there's no guarantee whether it will be bypassed or not, right? End of the day, it's keyword matching for it, right? So it's like all the intermediate protections the developers have to make sure that everything is in check. That happens for any early stage product. No one does it, but in the long run, people definitely do it. Yeah.
What's your point of view on identity federation in this like RAG space? So you have all these systems with all these documents, and different users have different levels of access. Should you have like a unique identity, a unique knowledge graph for every user? Is there a way to use prompts in the agent to, adhere to those rules, those users' access rules?
So whatever files you're uploading in the RAG pipeline, you can actually keep a separate identifier with them that this is for the public use, this is for the admin use. Like, have you heard about canary tokens? Yeah. Whenever a system prompt is going to be exposed, there's a canary token attached with it. So GPT, that is how GPT controls it, as far as I know. So you can actually map it with an identifier to make sure that this particular vector embedding, anyway document gets converted into a vector, right? This vector should be attached with an identifier. When it actually gets processed by the generator and when it gets outputted into the end user's console or UI, that token, if it's getting exposed, the access token of that user should be compared with that identifier, and then it should be validated and then only outputted. Otherwise, it should be stopped at that time only.
About the same question that we asked. So about the permission. So suppose you connect a SharePoint website,
Yeah.
right, to say Copilot Studio as an external data source or a connector. Then I don't think we need other access, because whoever has access to that SharePoint, right, only they should be able to retrieve information from that SharePoint. So that is already controlled by SharePoint. Isn't that so? Or do we need to have another level of access management?
So you are considering only the SharePoint perspective.
Yeah.
A SaaS application has a lot of agents which might have documents apart from SharePoint. Those documents can be a basic PDF also. How will you make sure that PDF is getting accessed only for that user? There might be PDFs, there might be videos. RAG can be anything, right? It's like a static memory or a permanent memory based on the requirement, but mainly static memory.
So you're suggesting canary tokens for that?
Yeah.